Hello, welcome back to our discussions of the Java ArrayList. Today we're going to look at this routine that has a couple of methods in it. Test string ArrayList and commented out right now, test employee ArrayList. We'll look at that later. For now, let's focus in on test string ArrayList. There's some review here, but there's also some new things. Starting with line 18. Notice how we declare this list of string. This is declaring according to the interface. List string. Notice how it's specified here. And the angle brackets here are empty. So once you specify it over in the declaration, you don't need to specify it again. It's not wrong to specify it again, so you could put in string here as long as they're consistent, but you don't need to. So again, declaring as an interface, but actually allocating an array list. This list of is a factory method, and this is all over the Java standard library, the of, which is essentially a factory method. Now, a factory method is a special method used to create objects. So list of, and this of will return an unmodifiable list, a read-only list of strings containing these elements. So it's a convenient way to create a list. So all I'd have to do then is specify all the strings here. And then I use it in the constructor of ArrayList because I want to modify it. If I just use this list of directly, there would be no objections on line 18. But when I try to modify it, it would say this is an unmodifiable list, a read-only list. So I can't modify it. So putting it inside the ArrayList constructor gives me a modifiable list. So I print it out here, and you can see the results here: red, green, blue, red. Red's in it twice. Then I remove the string red, and you can see that it disappears. In order for that to work, the remove string needs to be able to say equal. So what the remove method here does is it has an actual object type inside of it. There's an override for it that takes an index, and we've used that before, remove 3, and it would remove the element at index number 3. Here, it's going to have to look for the element that equals this. And so when it looks for it, it starts at the beginning of the string and says, do you match it? Finds it right away. It removes it, and it only removes one matching element there. And then it returns a Boolean value, which we're throwing away here. We're not paying attention to the Boolean value. It returns a Boolean value, true or false, whether or not I removed a value. But the task here of remove is to go searching in the list for an object that equals the object that's passed into it. Once it finds one, it'll remove it. If it doesn't find one, it will go to the end of the string and return false. Here we see that it successfully finds a string containing red and removes the first matching one. And here, so we have a remove here, requires equal. Then we're going to do a sort. So there's a class called collections that has a lot of static methods that are helper methods that have to do with collections. Here we're calling sort. In order to work, however, the sorted string needs to be comparable to another string and be able to say less than, I come before, equal to, I'm the same, greater to, I come after. So the object itself needs to say these things to the collections.sort. Collections.sort is a sort routine. It doesn't know the internals of any object that it's being passed. So it needs to know those things. So this tells us that string must be able to say that, less than, equal to, or greater than. Not too surprising. And then we have a sorted order of strings. Now our goal is to make test employee array list work the same way. That is, the same operations. We've been able to create the array list of employees. We're going to remove an employee, and then we're going to sort the list. Let's see what we need to do. First, let's take a quick look at the employee class. It's pretty simple. We have 3 private attributes: ID, name, and skill. 2 constructors, one that takes just the ID as the constructor, and then one that takes all 3 parameters as the constructor: ID, name, and skill. And that's the one we're using here to create these array list of employees here. ID 10, 20, 30, 40, and 10 again. We've duplicated Joe, who has the math skill at the end here. Let's uncomment this out and comment this one out so we can focus just on what's in front of us. I'll run this. And notice here, So hopefully you'll be able to recognize this as needing, this is the toString method of the object class. So recall that. The toString method of the object class is something disinherited, right? So there's an extends object here that's implied. The compiler puts it in. And then the toString method of the object. What can it do? It can say what class it is and where in memory is that particular object. It doesn't know anything about the business logic of employee, so that's all it can reasonably do. As we've seen, we need to override the string method here, and Eclipse will help us here. Override this, generate toString. We'll just take all the defaults, and now run it again. And we can see our toString method is working in a reasonable way. We have ID 10, Joe, skill math. Again, this toString method can be modified after you've generated it with Eclipse. It's not set in stone. It's software that you can control. So the idea is that the toString method is written for your business needs. So however you want to do toString, it's right for you, depending on the business needs of the object. Let's look at something else here. So we needed to do toString, we saw that, in order to have intelligible looking ArrayList down here. They're printing it 3 times. When it's first constructed, when I remove an employee, and when I, well, this is commented out when I sort the employee, right? So you can see that the ArrayList is untouched with all operations. So there's only 2 operations here, really, the creation and the removal. Right now I have the sort commented out. We'll look at that in a bit. But notice what's happening. The remove method is not working. How come it's not working? Does remove have a bug? Not likely. What needs to happen is, in order to be able to remove from the string, it needs to be able to say it's equal. So this should say employee, actually. So it's up to us as class designers to be able to design equal. That doesn't come out of the box, and there's no way it could. Again, those are business logic things. So how do we write equal? Well, object has toString, but it also has equal. And what object says is equal is what it can do at its level. It compares 2 objects' memory location. Are the memory locations the same? It doesn't look inside. That's a shallow comparison. It doesn't look inside the object for the object's content. That's what we need to do. And that's what we need. It's very similar thinking to overriding the toString method. We need to override toEqual, pardon, not toEqual. We need to override equal in order for this remove method to work. Let's do that. And Eclipse will help us because it's a standard thing to do. Right here. And we generate equals. And here, I'm just going to say I want to compare on ID. And just like toString, it's the business needs, the business logic needs of the class that dictate how these things should be written. There's no one right answer. So here we see equals, and now we're going to look at the employee ID and see if the 2 objects are equal or not. Let's run it now. All right, we can see that our equal methods now helps this remove method work. Again, remove, when you're removing an actual object by value, not by index, needs to traverse the entire array list from beginning to end, looking for an object equal to the object that it's passed. Well, now that we've overridden the equals method, it can do that. So it finds Joe, skill with math, the very first object in the list, and it removes it. So now, let's think about sorting. So sorting is a little bit more complicated than removing. Removing just needs equal, whereas sorting needs to be able to say less than, equal to, or greater than. And in this case, the compiler won't let us do this, right? So the compiler let us remove without writing equals because equals is already written. It has, object has an implementation for equals, and it might work for us. We needed to override equals to get it to work, but the wiring was already there. Here, this is objecting because the wiring, the less than, equal to, or greater than, is missing from employees. So we need to add that. That actually involves the use of an interface. Implements comparable. So right away we get a compiler error because, as we've seen, when we say we implement an interface, we need to implement its methods. And if we don't implement its methods, then we have a compiler error. The compiler will not compile this class until we've fulfilled our promise. We need to fulfill the contract that we signed when we said we implemented comparable. So Eclipse will help us here and add and implemented methods. Now Eclipse doesn't know how we want to compare to. That we need to write. So we'll do that. And I'm actually going to remove this compare to now that I see it. And I'm going to do a more modern, and that is specify this, and we'll get a better version of compare to. Both of them will work, but this is more convenient. So we need to say, instead of just a general comparable, we need to do comparable of a specific employee. And all that does is change this object to employee. Because now it knows what we want to do. Notice the override. We're overriding a method we inherited from object. So let's get into the details of this compare to method that we need to implement. Notice it takes an integer as a return type. And that's because there's a 3 state that this does. It's not a Boolean. Remember, it needs to say less than, equal to, or greater than. And this is a pretty standard way. It's not just Java. It's the C programming language started doing this initially, I think, but all programming languages I've seen have adopted this standard. And that is, when you have a comparison method, you use -1 or negative value to indicate less than, 0 to indicate equal to, 1 to indicate greater than. Well, what? We have the current object, that is what this refers to, our current object, and the object that we're being passed as a parameter. So if the current object is equal to what we're being passed as a parameter, we return 0 and return -1 to indicate less than, and 1 to indicate greater than. Those are the 3 values we should return for compare to work. But now we're returning compare to, so as far as the compiler is concerned, we've solved the problem, right? Now we know we're saying everything is equal, so it's not going to actually work, but we've told the compiler now that our objects are comparable to each other. So it's happy with us here. So let's run this. Now it won't do anything because we're saying every object is equal to every other object. So how can it sort that? It doesn't. Everything's equal. So everything stays in place. Now remember, all we want to do is compare an employee ID to say -1, 0, or 1. So that's where we're going to sort it on employee ID. Actually, I'll change my mind here because employee ID is already sorted. Let's sort it on the name. So we need to return -1, 0, and 1. Now we could write that code. However, and this is something to really keep in mind, if you're dealing with a standard Java object, that is something from an object created from the standard library, it probably already has compare to written on it. So let's use that. So employee O, so we'll do this. That is our current object, dot name, dot compare to, the other object, O, dot name. And we'll return that. And now this is unreachable code, so we'll delete that in. So be careful of that. Instead of the natural instinct would be to go ahead and write all the code, the wire of the code yourself to compare to. And strings are easy to compare. You can do that. But standard Java objects have compare to. Also, if you're using as you engineer your own objects, you're going to write compare to. If they need to be sorted, you make use of those existing methods if they exist, or create them if the classes are under your domain. Now let's run this. And now we have our objects being both supporting remove because we overwrote equals, and now we can sort because we made our objects comparable. they're comparable to each other, and we did that by implementing this interface. So if you need to do this yourself, you'll need comparable, and then inside the angle brackets, you put the same class name as the class you want to compare, and you have it. So important things to know: how to properly deal with removing and sorting your objects. Thank you.